Let's talk about how we can get the area between two curves using calculus. Okay, so hopefully you remember that the area underneath a function between a and b is the integral from a to b of that function. Okay, so if I did this integral, then that would give me all of this area all the way down to the x-axis. Okay, then if I do the integral from a to b of g of x, that would give me, hang on a second, that would give me all of this area. So if I want the area between f of x and g of x, then all I need to do is do the integral from a to b of the top function minus the integral from a to b of the bottom function. And that will give me the yellow area that I'm looking for. So that's the basic concept. The area between two curves is the integral from a to b of the top function minus the integral from a to b of the bottom function. So with that in mind, let's take a look at this problem right here. Determine the area between the functions 3x cubed minus x squared minus 10x, that's one function, and g of x is negative x squared plus 2x. Okay, so this brings up an interesting little situation here, because what's happening is I've got intersection points at -2, 0, at 0, 0, and at +2, 0. And you'll notice that between -2 and 0, the blue, the cubic, is above the quadratic, the red. But between 0 and +2, the quadratic is above the cubic. So we're going to have to do two different integrals. Okay, so our area is going to be the integral from -2 to 0 of f of x minus g of x dx plus the integral from 0 to 2 of g of x minus f of x. I have to switch because they switch positions. All right, now when we work this out, I'm going to go ahead and write this out. So this is going to be 3x cubed minus x squared minus 10x, and when I subtract g of x, I'm going to get plus x squared minus 2x dx, which works out to the integral from -2 to 0 of 3x cubed, and the x squareds cancel, and I get -12x dx plus the integral from 0 to +2 of negative x squared plus 2x, and then I'm going to subtract all of f of x, that's minus 3x cubed plus x squared plus 10x dx, which works out to the integral from 0 to +2 of negative 3x cubed minus 12x dx. Well, I went ahead and worked that out on my calculator, and you can see it right here. The first integral is 12, the second integral is also 12, so our total area, which would be all of this right here plus all of that right there, is 12 plus 12, which is 24 square units. Okay, and to do this on your calculator, remember you're going to hit your math button and then select number 9. Okay, let's look at this problem. So I have x equals 4 minus y squared, so that gives me this sideways parabola right here, and x equals y minus 2, which is giving me this line. Now, what we're going to do is we're going to do this in terms of y. Okay, so representative rectangle right here is going to have a height of dy, and this length right here of this rectangle is going to be the parabola minus the line. Okay, so what we're going to do is we're going to integrate from our lowest y coordinate to our highest y coordinate, and I'm going to do the rightmost function minus the leftmost function. So that's going to be 4 minus y squared minus y minus 2 dx. And when we simplify that integral, we're going to get 4 minus negative 2, which is 6, and then minus y squared, and then minus y. Well, that should be a dy, shouldn't it? dy. Okay, I'm going to do this on my calculator. I'll be right back. Alright, so I did it on my calculator, and the calculator doesn't care if it's in terms of x or y, so I just used x because it's easier. And you'll notice I get 20.83 repeating, and if I want to get a fraction, I hit math, convert to fraction, and that's 125/6 square units. Well, you're going to show up for me here? There we go. Okay. Alright, let's do one more example. I'm going to get the area bounded by these two functions, a quartic and a quadratic. And so it's going to be this area right here and that area right there and that area there. Now, since both of these functions are even, that means that they are symmetric with respect to the y-axis. So really, all I need to do is get half and then double my area. Okay? So I've got intersection points at -2, 0, at -1, 0, and then that's where the quadratic is above the quartic, and then the quartic is above the quadratic from -1 to 0, 0. So here we go. Our area is going to equal the integral, well, actually, it's going to equal twice the integral from -2 to -1 of the quadratic minus the quartic plus the integral from -1 to 1 of the quartic, which is x to the 4th minus 4x squared minus the quadratic. That's going to be minus x squared plus 4 dx. And I'm doubling it because I want to get the total area. This is only calculating half the area. Okay, I'm going to go to my calculator and I'll be right back. Okay, so I've done it in my calculator. Oh, and I also need to point out a correction I made. I had originally written -1 to 1. It should be -1 to 0 because you see we're stopping at 0 there for our halfway point. Okay, so I've got these two integrals. I put it all into one big step, and we get that the value of the area is 8 square units.